So y prime or dy over dx, I have to differentiate the quotient. So now we have to look carefully. It says find the derivative of the function. U normally is, this is a mistake in the book. So this should have been f of u or f of u of x, to be clear. So normally when we have u, we really mean u of x. So it's a function. It's not plain x. It's a function of x. So please keep that in mind. So as a note, normally, unless otherwise stated, u is a function of x. It could be a function of something else, but it's a function, not a variable. Okay, so I will copy the denominator because that's the easiest. I don't have to do much. E to u plus e to negative u, and it's squared. Now, if you're using my method with 1 and 2, then you will say 1 prime times 2 minus 1 times 2 prime. Okay, so if you want to do that, e to u prime is e to u times exactly minus exactly. So e to negative u times the inner function prime, which is negative 1 times u prime. Be very careful. So e to negative u multiplied by negative 1 times u prime. Again, it's not clear from the problem. If the problem considers u as a variable, not as a function, it's different. But since we're talking about the chain rule, I'm expecting them to say u is a function. But it doesn't say. Okay? So all this multiplied by the denominator. So e to u plus e to negative u. So this was 1 prime times 2. Yes?
In this case, did you say, are you treating u as a
Function of x.
Okay.
Yeah. Okay, and then now minus, right? Forgive me, of course, I ran out of room, so this should be continuing here, right? Okay, so I copy e to u minus e to negative u, and now I differentiate the bottom, which is e to u times u prime plus e to negative u times negative 1, because it's negative u prime, right? So it's negative 1 times u prime. So all this piece should be here. All this should be here. Now we can try to simplify this a little bit. We're not given u. So again, they may really consider u as just a variable. But I think this is more interesting. So now I copy the denominator, e to u plus e to negative u squared. So I hope you agree that these two change into positive. And I will factor out u prime. So u prime, in parentheses, e to u plus e to negative u. But I'm multiplying by e to u times e to negative u. So this piece, one more time, is e to u, but plus e to negative u. And this one is the same. So my question is, how do I square two terms? I have, yes? Awesome. Very good. And I'm going to do that. So when I square e to u, I copy the base. And what happens with the exponents? Multiply. Very good. Plus 2 times e to u times e to negative u and plus e to negative 2u. But how much is e to u times e to negative u? And this is something I tortured my pre-calculus with, which is the square root of something squared and plus 1, and we did exactly. Copy the base, add the exponents, I get 0, e to 0 is 1. Okay, so now...
But even if it wasn't e, if it was x, it would still be 0, correct? Or it'd still be
Yes, correct. Because you copy the base, the exponent is 0, so...
Can I ask?
Yes?
Like, you just have to, you don't have to write anything. Like, just so, let's go to the beginning when you, yes.
So I factored out u prime because it's common and it's right here in
Oh,
front.
no. I'm talking about all the way to the beginning. So there's EU.
Minus e to negative u
Yes.
over, yes.
All right, okay, I got that part.
So I differentiate the top, e to u times u prime, and then minus. E to negative u prime is e to negative u times negative u prime, which is negative 1 times u prime.
Okay.
Then I copy the denominator. And then I reversed. Minus, I copy the numerator and I differentiated the denominator. Better?
Yeah.
Perfect. So now I'm here with minus. So let's check. So again, it happens that e to u minus e to negative u is e to u minus e to negative u, but of course I have to factor out u prime. Okay, so of course I ran out of room, so I'm going to put that symbol, and I'm going to continue it here. And it's e to u minus e to negative u. I'm using the same formula. So I have e to 2u, but minus 2e to u, e to negative u, and plus e to negative 2u. Agreed? It was the same thing, but with minus, because this is minus e to negative u, and this is the same thing. So this piece and this piece are the same. So far, so good? Okay. Did I choose that problem? Okay, I'm sorry. Okay, so finally here it is. I have from both of them, I will factor out u prime. The denominator is this, and we will simplify it in a minute, although I always say don't try to expand the denominator in any way, shape, or form. So we'll see in a moment if we need to. So this is e to 2u, but plus 2 plus e to negative 2u. But minus, very good, minus e to 2u and plus 2 and minus e to negative 2u. I really hope that many go away, and I think that I can say that these two go away, and the top is 4. So this is 4 u prime. I don't need to do anything to the denominator, e to u plus e to negative u squared.
That's not like a test question, right?
No. No, because it's too long. I agree. Okay, so let's make one up, and I think...
you said you were going to do 40 something.
Yes, thank you. I was just going to go back. 42 on page 265. Where are you? 265, 265. And we have, yes, y equals x plus lambda. And this is raised to the 4th. Lambda is a number. So over x to the 4th plus lambda to the 4th. This is not exactly what I wanted, so I may have to show one more example after this, and we will make it up together. Ready? So now this is clear. X is a variable. It's not a bless you. It's not a function, and lambda is a number. You can replace it by 1500 if you want, or whatever. Bless you. So here it is. Y prime or dy over dx. Again, the quotient rule. The top prime, remember, is a function raised to a power. So we have the power rule combined with the chain rule.
You said this on page 265?
Yes.
Bless you. Were we just on page 205?
265. It's at the end of the chapter
Oh.
and the review problems.
Oh, okay.
So, can anyone dictate how do I differentiate this? 4x plus lambda to the
4. Third.
good times the inner function prime.
1.
1. I don't have to worry about it. Times the denominator minus, I copy the numerator, times the denominator prime.
3x.
Careful.
4x to the third.
4x to the third over the denominator squared. Perfect. Very good. What do you think I'm going to ask you to do now? Or tell me what to do?
Chart.
No.
Yeah. Joe will never get them.
How many terms are at the top?
A lot.
Maybe a few.
1, 2.
What do we mean by terms?
Wasn't it 2?
A quantity minus another quantity is 2 terms. Very good. Do they have anything in common?
4.
Yes. What else? X plus lambda to the, of course. So very good. Let's see what we have. What is left from the first term?
1. So x to the lambda. Right.
Minus
X to the left.
x to the third in front and in parentheses
X plus lambda.
thank you. See? You have no idea how much I tortured them with this. No idea. Because of this. So one more time. The 2 terms have 4 in common. They have x plus lambda in common. I have to choose the lowest power. From this term, I take 4 outside, all these, and this is left. Then I reach the negative sign. What is left? 4 is out. X cubed is in. And from these 4, I took 3 in front. So there must be 1 left. We agree?
Where's the minus x to the third?
X to the third is in front. Minus is copied. I put x cubed in front, and I remove 3 from these. Better? Everyone? Perfect. So, of course, now I have 4x plus lambda to the, to the third. And then I have to simplify in brackets. And that's what we did. So, I hope you notice that x to the fourth will go away with negative x to the fourth. So there is a lambda to the fourth minus lambda x cubed. We agree? X to the fourth minus x to the fourth go away. Lambda to the fourth minus x cubed times lambda. So in parentheses, minus lambda x cubed plus lambda to the fourth over x to the fourth minus lambda to the fourth, everything squared. And yes,
Plus 4.
I will, thank you. I would definitely factor out a negative lambda and put it in front. So this is negative 4 lambda x plus lambda cubed, and then I have x to the third plus lambda. Ooh, minus, minus, minus. I will change it in a moment. So this is minus. And that's completely simplified. And now if you say, do I need to do this? Yes, for chapter 4. Yes, and you'll see why. I think this was really good enough for what I had in mind. Now I would like to look at a word problem from page 206. It's not necessarily a word problem, but it's a page 206.
What number?
Haven't chosen. Let's look at 71. On 206. Let R of x, look at this. R of x is f of g of h. F of g of h of x. So this parentheses for x, I need parentheses for g, and I need parentheses for f. Let's see what they want. We are given h of 1 is 2. We are given g of 2 is 3. We are given h prime of 1, and that is 4. We are given g prime of 2, which is 5. And we're also given f prime of 3, which is 6. What do you think we're asked to find?
The
R prime of
x 1.
1 indeed.
What is it? That's an R?
R, yes, I'm sorry. This is R, this is R.
Oh.
Okay, so how do I determine the value of a function at x equals 1? I'm asking you find the R of 1 or R prime of 1. What do I have to find first? The function itself. Very good, the derivative. Perfect, awesome. So can anyone dictate R prime of x? Remember, we are not decomposing the function, we are differentiating. We start with the outer, then the inner, and then the innermost. So f prime of, very good, awesome, you got it. That's perfect. Times of, very good, times, very good. I take 1% credit for that, not more. Okay, now I'm ready to find R prime of 1. What will I do now? Replace
the
x with
One.
1. So f prime of g of h of 1 times g prime of h of 1 times h prime of 1.
Then you replace
Now I start backwards.
something else.
So this is given to us to be 4. Now this is given to us to be
G prime of 4.
2.
2. So wait for a second. Now I find the g prime of 2.
So it's 10.
So it's 5 indeed. So this is done for now. H of 1 again. G of 2 is 3. G of 2 is 3. And now I want f prime of 3.
6.
So it's 6 times 5 times 4. Here's how I do it. I will answer your question in just 1 second. 4 times 5 is easier, 20 times 6, and the answer is, that's it. Yes, please, John?
So h of 1.
Yes. H of 1 is 2.
But then 2 times g of 1.
G of. It's not multiplication. Do not confuse the function composition with a product.
So it's going to
So it's G of 2. It's not G times 2.
okay, I get that.
Better?
Yeah,
Perfect.
makes sense.
So that is 120. Any questions for me? Any questions? I'm really hoping that you're going to look at the recommended problems and come back with a list of questions. Okay. Yes, please.
The answer is 12.
4 times 5 is 20, times 6, 120. That's okay. Sorry about that. Implicit differentiation. Okay. So if I'm given a function, can I find f prime?
Yes.
But what if I'm given an equation and I cannot solve for f in order to find f prime?
Right.
So now I want to come back to something I couldn't do a few minutes ago.
Oh, that thing.
Okay, let's start with this. What page was this? 266. Okay, so x squared plus 2y squared equals 1, and whatever. So x squared plus 2y squared equals 1. Can I solve for y? I can,
Yes.
but then I will get two functions because I take the square root. No, that's not a good idea. So in this particular situation, we're asked to find dy over dx. Now this is very clear. If I'm asked to find dy over dx, what is y? Here's a hint. Is it a variable or a function? Yes, because I'm asked to find the derivative of y with respect to x, which is clear, which means y is a function of x. We must use this notation when we talk about implicit differentiation, not y prime, please. Will I give full credit if you use y prime? Yes. It's not a good idea, and you'll see in a moment why. But you can. Is it allowed? Yes. Is it correct? Yes. I don't recommend it. Okay?
Is you about to be a factor?
Say it again.
Is you about to come into play?
You said,
You, like.
yes, you can change this into u. And then you are asked du divided by dx.
Okay.
Yes. But in this case, we have y, which means y is a function of x if we are asked to determine this. Okay. We will differentiate both sides. Have we ever done this? Have we ever applied the same function to both sides? Yeah. We took the square root from both sides. We squared both sides. We applied natural log to both sides. If two numbers are equal, the logs are equal, and so on and so forth. So I'm allowed also to differentiate both sides. Okay, how do I differentiate x squared? Well, x squared is very clear. Is x a variable or a function? If we differentiate with respect to x, it must be a variable. So how much is x? Because this is a sum, this is not function composition, it's a sum of two functions. How do I differentiate x squared? Perfect, plus. Now the story is different. I have 2 times the function squared. Bring down 2, so it's 4, times,
X.
no, I didn't get there yet.
Y squared.
No, I didn't get there.
Y squared.
One more time. I bring 2 down and I subtract 1 from the power. Very good. Times, since this is a function, which I don't have, times, yes, but I prefer dy over dx. One more time. 2y squared prime is 2 times 2 times the inner function. So I differentiated the power first. It is the outer function, but then I have to differentiate, so 2 minus 1 times the inner function prime. I don't have y, so it's dy over dx. What about the right-hand side?
0.
That's it.
So why does y come down, but then we use the dy over dx?
Very good question. Two times y to 2 minus 1 times the inner function prime. 2 times y to n minus 1, which is 2 minus 1, times the inner function prime. Better? Is it?
If I could, can you show both of them at the same time?
Yes.
Both the problems.
Y squared prime is 2 times y times dy over dx.
Okay.
Better?
Yeah.
Very good. What am I after? What do I do? Yes, not everything. Move 2x first. So 4y dy over dx equals negative 2x. And finally, although, if you want, I don't have the function, there will be situations in which no one can solve. In this case, I can solve for the function, but it's not recommended because of the plus or minus. Okay, so then dy over dx is negative 2x divided by 4y, which is negative x over 2y. Now you can say, what did you accomplish? You found an expression for the derivative, but look, it depends on y and you don't have it. No. So what is the idea here? Is to determine a derivative of a function, the rate of change of a function or not, because this is not a function, it's two functions. Y is two functions, not one. So, but I can still determine the rate of change of y even when I don't have y. And now I can even evaluate it. Give me a point. Be very careful. If you give me x, you have to give me the corresponding y that is on this equation. So let's say x equals good. And then I have 2 squared, move to the other side is negative 1 divided by 2. Right. So maybe it's easier if we choose, it doesn't matter really. Okay, so we chose x equals 2, so that's 4. 1 minus 3. I'm in trouble with this one. Here it is. Can anyone tell me why I cannot plug in 2? Because I have y squared, which is negative 3/2, and that's not possible in real life, in real functions.
Do 20. X is 20.
If x is 20, good. Then I have 400, so then 2y squared. Still, I'm having the same difficulty. Okay, so is there any way I can get a point on this?
Yeah, do
The
0.
answer is only if I have 1 is 0 and 1 is 1, right? Only when x is 1 and y is 0 I can get 1. That's my only point. So let's take a look. So x equals 1, y equals 0. Is this a point on this equation? Yes, it is. When x is 1 and y is 0, I get 1. So now I can even evaluate, and that's how we write it, as x equals 1 and y equals 0. I'm in trouble. Again, why am I in trouble?
Yeah, divide by
There is
0.
no derivative. So I cannot evaluate. So let's take a look. Please choose anything you want. Page 215. Anything you want from 5 through 32. So we can illustrate this. Page 215. So
32.
I got an expression, but I cannot evaluate it. The expression is fine. It's negative x over 2y. But I cannot evaluate it for this point. I have to find another point where it exists and it's... Okay. Which one?
32.
32. Okay, good. Let's take a look at 32, which is y squared minus 4 equals x squared minus 5. We are asked to use implicit differentiation to find an equation of the tangent line to the curve at a given point, and the given point is 0, -2. I'm going to do first?
Plug in.
No, I cannot plug in, because if I plug in, I get a value, and when I differentiate both sides, what do I get? Thank you. So, say it again. Awesome, but not before. Not before. Say it again. Yes, absolutely. Do you want to differentiate a product on the left like that? Or a product on the right? No, I don't want to. So, what would I have to write?
1 to the 4th minus 1 equals x to the 4th minus 5x squared.
Very good. This is more human. And now I will differentiate both sides. We are asked to find dy over dx, although it's not clear in the problem. So it says unless you say use implicit differentiation to bind an equation, blah, 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 which really this is what it implies. X is the variable and y is the function. Good. So what do I get on the left-hand side?
4y 1/3 times
Thank you. Thank you, Caesar. Minus awesome. Now the other side is nice. What do I have? Awesome. Very good. One more time, what am I after? In which I will eventually plug in this number to find what? The slope of the tangent line at that point. Awesome. Well done, guys. So what do I do? Very good. dy over dx, what is left in parentheses? Awesome. Perfect. Well done. Thank you. And now I want to write dy over dx before I plug it in. Can anyone dictate this step?
4x third
Very good.
minus 10x over 4y to the cube minus 8.
Here is my observation, and please feel free to correct me at any point in time. I think you feel better about algebra now.
Yes.
Thank you. I think so. Your answers are more accurate than they used to be. Thank you, thank you, thank you. Here's what it is. We're determining dy over dx when x is, y is. So now what I have to do is plug it in. I plug in 0 for x. I plug in 0 for x. 0 divided by, and I have to check. Why do I have to check the answer in the denominator? Because I don't want 0 over 0, which means the derivative does not exist at that point. I have to check. So 4 times negative 8 is negative 32, and this is plus 16. I don't care for the number. The answer is, as long as it's not 0. And it's not. So I have that the slope is 0 at the point 0, negative 2. Now I'm asked to find the equation of the tangent line to the graph of blah, blah, when x is 0, y is negative 2, and the slope is 0. What type of point is this? Because I know I have two equations possible here. Y equals mx plus b, and the other one, y minus y1 equals the slope times x minus x1. And I want to use the easiest of the two. Do I have the
point.
please? You want to say?
I'm sorry.
Okay.
I'm so sorry.
What is this exactly? What point is this? The y-intercept. Since it is the y-intercept, this is what I'm going to use. Can I use the point slope form? For any point, but why? If I notice that this is the y-intercept, I want to use the easiest of the two. So what is the answer?
Y equals -2.
So the equation of the tangent line to the graph of y, which is not even a function, at the point 0, -2 is
Horizontal.
y equals -2. Any questions? Any questions? Any questions? Okay, I would like to choose one more problem and then we can stop.
My brain is exploding.
I don't think so.
Should start with commercial.
Okay, I need more paper. Okay, here it is. Please choose another problem in which we will determine. If you allow me, I will choose.
So one more
Yes,
question.
you choose the
choose.
best ones.
Very good.
The quickest one you got.
Okay, let's say
Let's take this you over you.
What is you over you?
let's say 11 on page 215. If we want to finish on time. So y cosine x equals x squared plus y squared. The problem is clearly stating, this time it's very nice. It clearly states, find dy over dx by implicit differentiation. So there is no discussion here, it's very clear, which means if I'm asked to find dy over dx, what do I know for sure?
If y is a function
Of
x.
exactly. What if I'm asked to find dy over dz?
Y is a function of z.
That's it.
Will it ever flip? Could it ever be dx over dy and this x is
Yes,
y? Okay.
if x is a function of y. Good. So how do I determine dy over dx? What do I have to do? No, and say it again. Differentiate the left-hand side and differentiate the right-hand side, keeping in mind that y is a function of x. I'm ready when you are. Be very careful. This is function 1 and this is function 2, which means we have to use the product rule. Okay, first function prime.
dy over dx.
Yes. Times the second function
So it's negative
plus, yes, you can already, but I would like to show what I'm doing, plus y times, awesome, equals, very good,
Plus 2y.
plus 2,
Plus 2y.
2 dy over dx.
2,
You get it.
Oh, 2 times y
perfect, times,
dy over dx.
because remember it's y squared. I have to bring the power down, subtract 1 from the power, and then the inner function prime. Are you with me?
Yes.
Awesome. Good. Let's simplify both sides a little bit. So cosine x times dy over dx minus y sine x equals 2x plus 2y dy over dx. Now I'm asking myself, what am I after? Good, which means this term has to go there, and that term has to come here. Which means what? So when I move this term to this side and this to this side, I change its sign. So cosine x minus 2y times dy over dx equals 2x plus y sine x. See if we understand this. I moved this term to this side, it became negative, and I have to factor out what I'm after, because no one can combine these. No one can combine cosine z minus 2yz. I have to factor out z. Are you with me? Yes? Yes?
What do you have to factor out?
dy over dz. This is the
Oh,
common.
okay.
This is the common factor. When I bring this in, the common factor is dy over dz. When I bring this in, it's that. Now I'm solving for this. Final step.
Divide the other side by cosine x.
Very good. No one can simplify this. No one can solve and do anything else here.